Okay guys, here we go with day 2, measuring segments. Not as many definitions today, woohoo! But some things that we have to start putting into practice. So the first thing we want to talk about is a coordinate. It's the real number that corresponds to a point. Okay, what exactly does that mean? Well, the coordinate is going to relate to the ruler postulate. Okay, so the ruler postulate states that every point on a line can be paired with a real number, which allows you to measure the length of segments. So think that there are some numbers that might be negative on a number line, but just because they're negative doesn't mean you can't find the distance between those 2 points. You'll see what I'm talking about in a little bit. So we're going to take those coordinates, whether positive or negative, and we're going to subtract them to find their measure. All right, and that's when we use the word distance. Okay, so the distance is the absolute value of the difference. Remember, difference stands for subtraction of their coordinates. So here we'll move along with that word coordinates again. Basically, in layman's terms, that means you subtract their values and you take the absolute value. Okay, sounds simple enough, right? Here's an example. I have this little line right here, and on it is point A and point B. All right, we're going to say that this is a coordinate, this lowercase a, and this is a coordinate, this lowercase b. Well, I can subtract these two from each other and take their absolute value, and that will give me the distance from A to B. Sounds good and all, but maybe we should actually do it with real numbers, right? That brings us to example number 2. Okay, so back to coordinates. This is -6. This little spot on the number line, that's its coordinate. Okay, so even though it's negative, it still has a coordinate. The question is, what is ST? What is the measure from S all the way to T? So we're going to take those coordinates. S is -4. And T is +8, and we're going to subtract them from each other. So we have S being -4 and T being +8. So we're going to subtract them and take the absolute value. -4 minus 8. That would give us -12. But remember, it's a distance. You can't have a negative distance, so that's why we need to take the absolute value. Therefore, the distance from S to T equals 12. All right, so using those coordinates, we can find the distance from one point to another. That's measuring a segment. To take this a step further, we're going to talk about the segment addition postulate. So now that we can find the lengths of segments, now we want to see how we can add them. So if there's 3 points, A, B, and C, and they're collinear, remember from last section, they lie on the same line, and B is somewhere between them, then we can say that AB plus BC equals AC. Again, Mrs. Black, that sounds great, but what exactly do you mean? What I mean is right here in this example. Here I have this distance from A to B, and I have this distance from B to C. All right, they both have B in common, right? It's AB and BC. That means I can skip over that B, and I will have the entire segment AC. AB plus BC will give me the entire segment AC. That's segment addition. Let's use it with real numbers. Okay, EG is 59. All right, so all the way from E all the way down here to G is 59. We want to know what EF and FG are. Okay, we want to figure out their measures. Unfortunately, it gives us an expression. It doesn't give us an answer. It says that EF is equal to 8x minus 4, and that FG is equal to 4x plus 1. Okay, well that's great. using segment addition, can we figure this out? We sure can. I'm going to take EF, this segment, add it to FG, this segment, and set it equal to the entire segment. So using these two expressions, I'm going to add them together and set it equal to the length of the entire segment. Here it is, 8x minus 14 plus 4x plus 1 equals 59. I'm going to work my magic and combine some like terms. I'm going to end up with 12x minus 13 equals 59. I'm going to add 13 to both sides and end up with 12x equals 72. And once I divide by 12, I'll have x equals 6. Okay, you're not done because it wasn't asking me to solve for x. It was saying what is EF and what is FG. So I'm going to take that 6 and plug it back in. So EF is equal to 8 times 6 minus 14. We simplify and we get 48 minus 14, which equals 34. So EF is 34. We do the same thing for FG. 4 times 6 plus 1 equals 24 plus 1 equals 25. So FG equals 25. All right, that is segment addition postulate. All right, moving along here, we're going to talk about congruent. And congruent is when two segments have the same length. So think of equal, they're the same measure, but it deals with a segment, not numbers. So we're going to say that these segments have the two length. And how do you write it? I forgot my trusty green highlighter here. You're going to write it an equal sign with a little squiggly, or with a hat on top, a little bloop. So that's congruent, meaning that two segments have the same length. Then there is midpoint. That is the point that divides a segment into two congruent parts. It basically cuts it in half. So you're going to have a segment, right? And somewhere right in the middle will be its midpoint, which means that this piece and this piece are equal or congruent. Okay, then we move on to a segment bisector. It's a point on a line, array, or another segment that intersects a segment at its midpoint. So, right here, this segment bisector, it would cut through. This would be a segment bisector because it intersects right at this segment's midpoint. So midpoint is that middle point, right? Equal on both sides, and the segment bisector cuts through that. So let's look at this as an example right here. And again, I forgot my color coding. I'm sorry, guys. Okay, we're looking at this figure down here, and we have segment AC, all right, and B is the midpoint there. You'll notice I highlighted these two little dashes in purple. All right, I highlighted them in purple to show you these two lines. Whenever you see that a segment has matching lines, that means they're congruent. So if this one had 2 and that one had 3, it would not be congruent. But because they both have two lines like that, they are congruent. All right, B is the midpoint right here, and the segment bisector right here is this line L. Remember, lowercase letter, line L. All right, and these matching dashes, again, indicate congruent segments. So let's do yet another example. Q is the midpoint of PR, so it's going to be right smack dab in the middle, Q, that midpoint. They want you to find PQ, QR, and PR. All right, so here's our segment. I know that PQ is 6x equals 7, and QR is 5x plus 1. All right, it's the midpoint. So we know that this segment right here, PQ and QR, are congruent. Because they're congruent, they're the same. So we're going to take each of these expressions and set them equal to each other. All right, PQ and QR. These three little dots are the symbol for therefore. So therefore, I can take 6x minus 7, set it equal to 5x plus 1, and start solving. I want to get all of my x's on one side, so I'm going to subtract 5x from both sides, and I'll end up with x minus 7 equals 1. I want to get x alone again, add 7 and add 7, x equals 8. All right, again, that's just x. They're asking me to solve for PQ, QR, and PR, not just x. I got to plug that x back in. Okay, well, when I plug that x back in, I do 6 times 8, what my x value was, and minus 7. Well, 6 times 8 is 48, minus 7 is 41. Okay, QR now, 5 times 8 plus 1. 40 plus 1 is 41. These numbers should both be the same because Q is their midpoint, right? So PQ and QR are congruent, or they are equal. Now we need to find PR, the length of the whole segment. Well, we can just take both of those segments and add them together, or multiply them by 2. Multiply by 2, we can write times 2. And we'll get that the whole segment, PR, is 82. And that's it for tonight, guys.